All right, so selecting strategies, as I mentioned earlier, right? One of the benefits, right, of going with delegate and composite as opposed to having gone the inheritance way, is that we can add runtime, based on different logic that we might have. We could, combine these strategies that are self-contained, that they don't depend on each other, that we can combine them dynamically in any which way we want, right, without having to have any hard-coded particular inheritance chain. Right? So let's take a look at an example on why would you want to do this, right? That and the example is the one I hinted at earlier, that perhaps you're making a computer player, right? That you want to automate and want to play against a non-human player, and you like to be able to configure how sophisticated that player is, right? That either you want an easy or harder or medium size, right? And perhaps these different strategies of easy, harder, or medium are actually combinations, multiple different combinations of strategies that you've already built. Yes, that you can create any chain that you want dynamically, and then just map them to this map of different strategies that are different chains of these strategies. So here we have a tic-tac-toe game that you want to play against, right? A non-human player. And at runtime, you can mix and match these composing strategies into these various chains of easy, medium, and hard. And based on the whether you chose easy, whether you chose medium, or whether you chose hard, that's just going to be a combination of multiple strategies. Right? If it's easy, perhaps you can combine with try to. You can combine try the corners. You try the well, obviously you're trying to play to win, but you remove the sophisticated strategy of trying to block, trying to play for the corners. Yes. So you only have those two: play to win, where indeed if I see an empty spot where I'm about to win, take that. But I'm going to handicap the player so that it's not smart enough to identify corners. It's not smart enough to identify blocking me. Right? It's too dumb. Right? So I'm removing those strategies. So I'm only combining those two: play to win and any open square. Right? So I can dynamically arbitrarily choose that, or medium. Perhaps I can combine the any open square with the don't lose. Right? Don't lose meaning if I see that that the other person is about to win, I will block them, right? Or some other strategy, and the output of that, it'll be combined with another try to. See that? So try to is the output of the next try to. Right? Strategies within strategies, and obviously combine it with the play to win. Both of them always checking to see if the other strategy return null. If it's null, then I'll go and fall back, do it to my fallback strategy, right? And hard, hard, checks for everything. Right? Open squares, open corners, blocking, and finally play to win, right? And again, I can create these combinations, or if I don't know what the correct combination is, right? I could have like Google's Go, right? It can search an immense search space of what the winning strategy is for playing Go, and then beat the world champion. I think it was able to learn all by itself, be a superhuman within hours with no human intervention, which is pretty scary. So you would have in some other part of the program, right? You would depending on the setting that the person chose, right? It would the next play that the computer user would be using that particular strategy, either easy strategy, the medium strategy, or the hard strategy, and would calculate their next position, their next move based on these various strategies. And again, this could be done dynamically. Right, and they could be. You could even have a strategy where the we can ask for a cheat. We can cheat, and the user can says, oh, I don't know where to play, and ask the computer, where would you play, right? And the computer say, well, this is the move that I would choose, right? And then you can play exactly and kind of foresee what the player's thinking, what the other player's thinking. Yes. I'm sorry?
Can you write like a try and
Sure. Yeah, exactly. Yeah. Where that chain would be completely dynamic. It could be an array or a list, right? Or a map that maybe at the first you don't know what the order is, right? And you can randomly identify and then sort them in the particular best case that would give you the better chances. Yeah. Yeah, these two lists are hard-coded, right, where you have try, but you can certainly put this in a loop, right? Yeah, so this is kind of like a cheat strategy. The cheat strategy where you can ask the opponent and says, well, what are you thinking, right? And the computer will tell you, well, this is where I would move, right? And perhaps cheat and move into where they're thinking. Also, because we have automated these all these moves, right? This would be a perfect test harness, right? That you can already calculate what all these moves are going to be, right? And create perhaps a long string of what all these operations would be, right? I would move into 0, 0, into 1, 2, 3, 4, and whatnot. Yes, based on that particular strategy. And that would be already my expected value, the expected value that I would expect from a particular strategy, right? And then I can take those as expected values and compare them against implementations of the strategy. So I've automated an entire test harness, right? And where players could perhaps play against each other. Two non-human players could just play against each other and verify that my strategies are working, right? So this would make it very easy to test them independently. Right, using the appendable that can append the different outputs of these strategies and then compare them against what the expected values are.